Welcome guys, good morning everyone. Thank you for watching our videos. Thank you for subscribing to our channel Tech Talks Uganda. So we are still proceeding with examples concerning variance and standard deviation, but for this particular case the example is somehow different because here the adverse has to determine the variance then using the working mean, which we never had in the previous cases. So here we have one example that reads, the table below shows the heights of students in a certain school. So we have height ranging from 154, 155, 160, 164, 171, 180, and with their corresponding frequency of 4, 6, 8, 5, 4, 3 respectively. So the question is saying that determine the variance and the standard deviation using the working mean of 160. So before we continue to the question or to the tackling of this question, we need to first know how we calculate variance given standard and standard deviation given working mean or assumed mean. If you try to recall, we said that if you have assumed mean, we get deviation d from x minus the assumed mean, where x is the variable. So if you are calculating variance now given assumed mean, what you need to put into your mind that now we replace x, where we had x, we replace it with d. For this instance, variance, we are calculating variance which we denoted as var of x by summation of fx squared out of summation of f minus summation of fx out of summation of f. Now, since they have given us assumed mean, we are not going to use the same case. Remember, before, if they had just stopped here, this is the case we are going to use. But now they have given us what we call assumed mean. And when you are given assumed mean, it is obvious that you will not use x, implying that we shall not see this value of x anywhere in our expression. Where does it go? That value of x is substituted by d, which comes from this formula saying that d equals to x which are the variable minus assumed mean or the working mean which is given. So this one will bring us to the formula of variance. Let us denote it as var of x will be equals to summation of f times d. We said where there is x, shall replace it with d, but this d is squared minus out of summation of f, and then minus summation of fd out of summation of f. But this summation of fd out of summation f is all of it squared. So that one become our new variance when you are given the standard deviation. So when you are given the standard deviation, you don't use the other formula where you have x. So this is the formula which we shall use to calculate our variance given assumed mean. And then we say where d equals to x minus a. So that's the formula of calculating variance. But also they want us to get the formula calculating standard deviation. So Remember what we said, that standard deviation, we denoted it as SAD is given by square root of variance of x. So this means that our standard deviation will become summation of FD squared out of summation of F minus the square of summation of FD out of summation of F. So these are the two formulas which shall be used to calculate variance and standard deviation given working mean and or assumed mean. So this one, after seeing a little bit of this introduction, let us go to the working. Now, according to our example, remember what we said, that if you are given such an example, it's better to start with frequency distribution table such that your work can be simplified and then you can be more organized. So what we need to do, we need to first do a frequency distribution table of this data which is given. We said when we are doing frequency distribution table, we start with the class which we called X. So for this case, we are going to let our X be the height of those students. The height of the student, which is X, is ranging from 154, 155, 160, 164, 171, 180 and 180. So immediately we say, after finishing the first column, it is better to put frequency, or the column having frequency, as the next. So here our second column of frequency will be the next, and it has 4, 6, 8, 5, 4 and 3. Since the frequency is given, there is no need to include a third column, because now we have the frequency, and then going back the other side, it will be just consuming our time. And we said immediately you finish putting all the coding values of frequency, you must get the summation of frequency. So you get its total, which equals to, you add from the top up to the last one. So you have 4 plus 6, which is 10, then plus 8, which is 18, plus 5, which is 23, then plus 4, which is 27, plus 3, we get 30. This one become our summation of F. Then said once you are given assumed mean, we need to get the value of X. Once you have assumed mean, we need to get the value of X minus A, which is the deviation. So here we shall look for value of deviation D, which is given by X minus A. But what is our A? A is the assumed mean. So we shall now substitute A with the assumed mean, which is given in the question, and that should mean is 160. Then let me use my calculator. So x minus 160, we start 150 minus 150, we shall get minus 6. Then 155 minus 160, we shall get minus 5. This one will give us a 0. Then this one will give us a positive 6. 160, this one will give us about 11. And then this one will give us 20. So that's our deviation D. So after finishing deviation D, as we have looked before, when we are starting this question, we said that variance, to find it, we need to have the summation of frequency times its D, which is the deviation, and then also we need to have the summation of frequency and deviation squared. So we need to get the column of FD and the column of FD, and the column of FD, and the column of FD squared. So those are the two columns which are remaining. So we start multiplying. For FD, we shall multiply 4 times the negative 24. 4 times the negative 6, we shall get negative 24. Then 6 times 5, we get negative 30. 8 times 0, we shall get 0. Then 5 times 6, we shall get 30. And then 4 times 11, we shall get 44. Then 3 times 20, we shall get 60. So we shall add and get the total summation of FD. So our total summation of FD is given by total summation of FD. We shall add from top up to bottom, that is negative 24 plus negative 30, then plus 30 plus 44 plus 60. We shall get summation of FD as 80. So that is our summation of FD. Then we shall go ahead and look for frequency, the column for F times D squared. Since we have D, we shall just look at that column for F times D squared. Remember, when you take D squared, everything in this column become positive. Because when you get negative 6 squared, it will become positive 36 because of negative times a negative. And then when you get negative 5, still the same story will happen, and then this one we shall have positive, implying that everything under here will become positive. So let us go ahead and look at F4 times D squared. So our F is 4 times D squared, which is 6. We shall get 144. Then we have 6. 6 times 5 squared, we shall have 150. Then still this one we shall get as 0, because any number multiplied by 0 is will still become a 0. So here we shall have 5 times 6 squared, we shall have 180, and then 4 times 11 squared, shall get 484. Then we have 3 times 20 squared, we shall get 1200. That's when we have used it at once. But in case you don't want to be confused with this thing or to make mistake due to multiplication and other things, it is advisable that you first get the column for d squared, and then after getting the column for d squared, you can then go ahead and multiply f times that d squared which you have got. Since before you had even got the column of d, so it will come easier for you to multiply d times d, or to get the d squared. Then immediately after finishing that column, you have said you must get the summation of fd squared. So summation of fd squared will be given by adding whatever variables, which is the values which are in the column of fd squared. So we have the first one as 144 plus 150 plus 0 plus 180 plus 484 plus 200. So the answer you get on your calculator